Are you eating right, but not seeing the weight changes you expected? Have you ever wondered why some people can eat the same things and still lose weight more easily while others gain it? Body weight involves many interacting factors: diet, exercise, sleep, and genetics. But recent research has revealed an important piece that's been overlooked: the gut microbiome. Why does your gut environment matter? This slide explains the full picture. Your gut is estimated to harbor tens of trillions of microorganisms. The types and ratios of those bacteria influence how efficiently your body extracts energy from food. They're also involved in regulating the hormones that control your hunger and satiety. And through the gut wall's barrier function, they influence systemic inflammation levels throughout your entire body. This is the scientific foundation built by over 2 decades of microbiome research. It's not a universal solution, but it's a factor you can't ignore when it comes to weight management. And you can start changing it with today's meals. Today, let me show you the science behind this. First, let's establish the foundation for understanding the relationship between gut bacteria and body weight. In 2006, a landmark study by Turnbaugh and colleagues was published in Nature. In obese mice, bacteria from the phylum Firmicutes were dominant, while in lean mice, Bacteroidetes held the advantage. The researchers transplanted gut bacteria from obese mice into germ-free mice. Those germ-free mice then accumulated significantly more fat, even on the same diet. In mouse studies, this was an important finding, suggesting that the gut microbiome can influence fat accumulation. However, subsequent large-scale human studies revealed the picture is far more complex. The association between the Firmicutes to Bacteroidetes ratio and obesity in humans has been inconsistent across studies. Some research shows a connection, other studies do not. A 2023 Nature Reviews microbiology paper concluded that this ratio is not an absolute indicator. So what does modern science emphasize instead? Rather than simple phylum-level ratios, it's about what the bacteria actually do, their function, their capacity to produce short-chain fatty acids, their metabolism of bile acids, and their impact on the gut wall barrier, and the overall diversity of the gut microbiome. With this perspective, let's look at how the gut environment actually works. This is the most important point of today's video. Through what mechanisms do gut bacteria influence body weight? At the core of it all are short-chain fatty acids. When you eat dietary fiber, your gut bacteria ferment it. This process produces short-chain fatty acids, butyrate, propionate, and acetate. These short-chain fatty acids stimulate receptors called FFAR2 and FFAR3 on L cells lining the intestinal wall. Stimulated L cells then release the satiety hormones PYY and GLP-1. This pathway for appetite regulation is supported by multiple studies. However, the magnitude of the hormonal increase varies significantly based on the type and amount of fiber consumed, as well as individual differences. Have you heard of GLP-1? This is the same pathway targeted by drugs like Ozempic and Wegovy, medications that stimulate GLP-1 receptors. But there's an important distinction to make here. When this pathway is activated naturally through diet and gut bacteria, the acute effects are not as powerful as those produced by medication. However, there is tremendous value in being able to chronically activate this physiological pathway without relying on drugs. And here's the latest development. Obesity medications are now evolving beyond GLP-1 alone, advancing toward multi-agonists that simultaneously activate both GIP and GLP-1. Dietary fiber and fermented foods are not replacements for these medications. They are most accurately understood as the foundation of long-term lifestyle intervention. Let me explain another pathway through which gut bacteria influence body weight. The gut wall barrier function. A healthy gut wall forms a precise barrier separating the intestinal contents from the bloodstream. Cells are tightly bound together by structures called tight junctions. The system is designed to allow only essential nutrients through while blocking harmful substances. However, when the balance of gut bacteria is disrupted, this barrier can weaken. Gaps form in the tight junctions, and LPS lipopolysaccharide can enter the bloodstream. LPS is a component of the cell walls of bacteria living in the intestine. When LPS infiltrates the blood, toll-like receptor 4 of the immune system reacts, triggering the release of inflammatory cytokines. This condition is called metabolic endotoxemia. Research suggests this inflammation may interfere with insulin receptor signaling and contribute to insulin resistance. Let me be precise about this. The causal relationship of this pathway in humans is still under investigation, and individual variation is substantial. This is not a simple story where a leaky gut inevitably leads to weight gain. However, it is scientifically supported that maintaining the integrity of the gut wall barrier is important for metabolic stability. Now let's organize the practical methods for optimizing your gut environment into 3 concrete strategies. The first strategy is to increase your dietary fiber intake. The recommended daily intake in the US is 25 to 38 grams for adults, varying by caloric intake and sex. Start by setting a goal to simply eat more than you do today. Combining half a cup of lentils, 1 apple, and 2 slices of whole grain bread daily gets you close to 25 grams. The average American consumes only about 15 grams of fiber per day. That means most people are getting roughly half the recommended amount. The second strategy is to incorporate fermented foods into your daily diet. A 2021 Stanford University study showed that fermented food consumption increased gut diversity and lowered inflammatory markers. Plain yogurt, kefir, kimchi, and sauerkraut are particularly effective choices. When choosing, look for options that are unsweetened or low in sugar. For high-sodium foods like kimchi, be mindful of quantity. Aim for 1 serving per day. The third strategy is to reduce ultra-processed foods. Not all processed foods are bad. Frozen vegetables and whole grain bread are also processed foods. The real problem is ultra-processed foods that contain high amounts of additives, artificial sweeteners, and refined oils. A 2024 BMJ study shows a strong association between ultra-processed foods and obesity and metabolic disease. By combining these 3 strategies, your gut environment will start to change at a fundamental level. Let me introduce more advanced scientific insights for optimizing your gut environment. First, let's talk about probiotics. Multiple meta-analyses on products containing lactobacillus and bifidobacterium have reported statistically significant improvements in body weight and BMI. The magnitude of the effect varies by strain, with reported weight reductions of approximately 1 to 3 pounds. What's important is that this is not a dramatic weight loss effect. It's a supplementary effect that becomes meaningful when combined with diet and exercise. And there's a bacterium at the forefront of science that researchers are paying close attention to: Akkermansia mucinifera. A 2019 Nature Medicine study confirmed across multiple lines of research that this bacterium is found in lower amounts in obese and diabetic individuals, and in greater amounts in lean individuals. Akkermansia is being rapidly researched as a next-generation beneficial bacterium with the potential to strengthen gut wall barrier function and improve metabolism. What is effective for increasing this bacterium? Foods rich in polyphenols. Berries like blueberries, green tea, and pomegranate have been shown to support the growth of this bacterium. From the outdated F/B ratio to the functional diversity of active bacteria, the science of gut health is evolving rapidly. Now let's pull together the key takeaways from today. Here's today's summary. First, the gut microbiome is one of the critical factors influencing body weight. Through energy extraction efficiency from food, regulation of satiety hormones, and maintenance of the gut wall barrier, gut bacteria are multidimensionally involved in metabolism. It's worth optimizing alongside diet, exercise, and sleep. Second, the combination of dietary fiber and fermented foods represents the intervention with the strongest scientific evidence. Increasing fiber to 25 to 38 grams per day promotes short-chain fatty acid production, and fermented foods, as the Stanford study demonstrates, increase gut diversity and suppress inflammation. Berries and green tea that cultivate Akkermansia are also options you can add starting today. Third, your gut environment is something you build up and something you can also break down. Excessive consumption of ultra-processed foods damages gut diversity, and unnecessary antibiotic use brings changes that take time to recover from. With a long-term perspective, the accumulation of daily choices shapes your gut environment. What is one thing you'll change starting with today's meals? Adding a fermented food, or including one more fiber-rich dish? Share your strategy in the comments below. Thanks for investing in your health today. Now that you understand the relationship between gut bacteria and body weight, you've already begun to see your health not as something left to chance, but as something you can manage scientifically. On this channel, we break down how the human body works and how to optimize your health, all grounded in evidence. Subscribe and turn on notifications so we can keep exploring the science of your body together. Until next time.